Okay, hello friends. Today we are going to look at logical reasoning. And logical reasoning, which aspect of logical reasoning are we going to consider is called the truth table. So we're going to prepare a truth table for this P, not P conjunction, not Q. Is equivalent to bracket open P disjunction, not P disjunction Q. So how do we prepare a truth table for this problem? Now, what you need to know is that logic is a science of reasoning and thinking. Science of reasoning and thinking, or mathematics of reasoning. So, now another thing you need to know about logical reasoning is that there's what we call logical statements. So, logical statements can either be true or false. It cannot be both. So, for example, one can say today is Wednesday. Is it true that today is Wednesday? Or is it true that today is Thursday? If it's either today is Wednesday or it's false that today is not Wednesday. So a logical statement is either true or false. So what we have here now, we also have what we call, let's say, logical connectives. Connectives join two or more logical statements together. Connectives like the disjunction, the not, the equivalence. We also have connectives like so this one is the conjunction and this one is the disjunction. So these ones are called logical connectives. There are many logical connectives which you need to know. But for the purpose of this class and this question now, we are going to answer this question creating what we call the truth table. Now, looking at the board, looking at the question, we have two alphabets, P and Q, showing that we have two logical statements. Yeah. And these two logical statements, since we have two logical statements, we're going to have two here. And logical statements is either true or false. So true or false. There are two things now. So we're going to have these two now, two things, 2 raised to power 2. The two logical statements raised to power logical statement which is either true or what? False. So 2 raised to power 2 is 4. Meaning that we are going to have our P, we're going to have what? Our Q. Then we are going to create 4 tables, which is want to go 1, 2, 3. 1, 2, 3, 4. Guys, we have been able to create 4 subtables. That's what we have. Then after creating that 4 subtables that we have, the next thing we're going to do is how many truths will fill this table and how many false will fill the first table. We'll come here and have 4 divided by 2. 4 divided by 2 is 2 equals to 2. So we're going to have true, 2 of it, false, false. We have completed this table now. Then this other one now will be how many true and false will alternate themselves in this table. We're going to have 2 divided by 2 and the result is equals to 1. So we're going to have true, false, true, false. We have been able to create that table now. We have been able to create this table. The next thing we're going to look at is how to find negation P. Negation P. What is negation P? Negation P is the opposite of P. The opposite of a logical statement is called negation or not. For example, the opposite of go is come and the opposite of come is go. So what is the opposite of true? The opposite of true is false and the opposite of false is true. So that's what I want you to know. So negation P, if the statement is not true, either that statement is false. If the statement is not true, that statement will be false. If the statement is not false, that statement will be true. If the statement is not false, that statement will surely be true. Then we are going to create a table for negation Q. So sometimes it is written like this or a bar like this. So I'm using different forms so that anyone you see in your materials, you know. So negation Q. If the statement is not true, false. If the statement is not false, true. If the statement is not true, false. If the statement is not false, true. We have been able to create that table now. The next thing we're going to do, create table we are going to create now is we're going to create a table for negation P conjunction negation Q. Negation P conjunction negation Q. Now, in conjunction, the only time this table becomes true using conjunction, which is and, is when both tables are true. When both negation P and negation Q are true, otherwise false. Meaning that the only time these two tables becomes true is when you have true here and true here. Using the word negation, using the word conjunction. It's only when you have true here and true here. Otherwise, what you're going to have, the result, if you don't have that true, the result will always be false. For example, false is false, yeah? False true is false using conjunction. True false is false. Then true, we have seen true now, yeah? Using conjunction is true. So that's what you need to know. Then we move to the next table. We are going to create a table. We have been able to create this one now. So we are going to create a table for P disjunction Q. Now P disjunction Q. After creating the table, we are going to now finally create a table for P negation P disjunction Q. So let's go. Now how do we create P disjunction Q? The opposite of conjunction is disjunction. So in our disjunction, this other one, the only time you have true in the table is when you have true, otherwise false. Why this other one, the only time you have false is when you have false, otherwise true. So disjunction is seen as the opposite of conjunction, and conjunction is seen as the opposite of disjunction. But don't confuse it with negation, because negation is generally the opposite of a logical statement. So P disjunction Q. So this is P and this is Q. So the only time this table becomes false is when you have false, otherwise true, using disjunction. So true is true. True false is true. False true using disjunction is true. False is false. Then the last but not the least table you are going to prepare now is the table will now be P disjunction Q. The negation of that statement now is what you are preparing now. So it will now be the negation of this. If a statement is not true, false. If a statement is not true, false. If a statement is not true, false. If a statement is not false, that statement is true. So the next thing we're going to look at is, I want you to check this place. I want you to check this, and this. Why star? You have false, true. False, true. Which is what you are asked, the question you were given for you to prove that negation P conjunction negation Q is equivalent to P disjunction Q negation. So that is what I want you to, or negation P disjunction Q, and that negation covers everything. So this is what you have, and we have been able to prepare the truth table. I've been able to prepare the truth table. There are other methods used in preparing the truth table which you might like. I'm going to upload videos on that method of preparing the truth table. But if you understand this one, drop your comments or your reply on the comment section, and do remember to subscribe. Then I will be uploading a truth table for another method which you might like that method. Can go through the video over and over again, and do remember to subscribe to our YouTube channel. Bye bye.